Hey guys! Today we are going to take a look at the cross product of two vectors. So this is just another operation we do with vectors. And so previously we did the dot product, and the primary difference between the cross product and the dot product is that the dot product gave us a scalar. The cross product will give us a vector. And so maybe that's not actually the primary difference, but that's the easiest way to distinguish between the two. So anyway, so the cross product of two vectors, A and B with an angle alpha between A and B, when positioned tail to tail, is a vector quantity, with the following properties. So here we go. So first of all, the magnitude. So the magnitude of A cross B, and that's how we write it, is just your traditional multiplication symbol, okay, or a cross product because it's a cross, is equal to, when we take the magnitude of of A, the magnitude of B, and then we multiply by sine alpha. Okay. So that's the first one. So that's we'll call that property A. Okay. Property B is that the cross product, what it is that it gives us. What it is it's the it's a vector that's perpendicular to both A and B. Okay. So it is perpendicular to both A and B. Okay. So for instance, if you had your desk and you had two vectors lying on your desk along that plane, then the cross product would be sticking straight out of your desk, straight up towards the ceiling. Okay? Now, sometimes people will say that they then they form the right-handed system, which, I don't know, it's just when you stick your... Let's see if we can draw this. You ready? So there's your thumb, and you stick your finger out, and you stick your middle finger this way with our... Hey, that's actually pretty good. I think that's the best drawing I've ever done. And so what this does is this forms, so this would be the X going this way. That'd be X. Why is that one X? I don't know. This one would be your Y. Why is that one your Y? I don't know. It just is. And the Z goes this way. And so the idea is they're all perpendicular to each other. Okay? And this is a rule people will mention from time to time. If I'm being honest, I've never used the right-hand rule in my life, and I don't really see a lot of, use for it, but whatever. It doesn't matter. Anyway, there we go. So there's A and B, and keep in mind that this angle here isn't necessarily 90 degrees. That can be anything, okay? But what we do know is that then this angle is 90 degrees and this angle is 90 degrees. Okay? And so that's what the cross product gives us. Okay? And you can see that's very useful in a lot of applications. To be honest, more so than the dot product, or at least I feel. So there are some special cases here. So if A and B are collinear, okay, and it doesn't matter if they're going in the same direction or not, okay, as long as they're collinear, so alpha is equal to 0 or 180, then the cross product of these two vectors would just be equal to 0, okay? More specifically, it would be the 0 vector, I suppose, yeah, okay? Because it is a vector value, so it would be the 0 vector. Okay, and that kind of makes sense logically, because how could you come up with, if you've got two vectors going exactly the same direction, how could you come up with a specific vector that is perpendicular to both? Because really there should be an infinite number that way. So that it mathematically works out to be the 0 vector too, because that's how math works. Okay. Anyway, if they're perpendicular, then let's see, then it's, well, hold on, sorry. Then the, yeah, well, okay, so then well, this is why I'm messed up, is because that should be like that. Then if they're perpendicular, all right, now I got it. So the cross product then, or the magnitude of the cross product will be the maximum possible, and it will just be equal to those two multiplied, so that will be the maximum. Okay? There we go. All right. Sorry, I had a little blank there because I'd made a typo. But anyway, if we have A and B, and these three lines mean that the vectors are congruent. So the vectors are exactly the same. Okay? So it's just, they're exactly the same. Okay? If that is the case, then again, it's just the zero vector. And so we could also write this. This rule could be written just as A cross A is equal to the zero vector. Okay, it's the same thing, right? Okay. And again, I mean, that follows this special Ka. It's the same idea, right? Anyway. So example number 1, the magnitudes of two vectors are 2 and 3 respectively. The angle between them is 60 degrees. So we're going to find the magnitude of the cross product for these vectors. So this is fairly straightforward. So we're just going to say A cross B, and we're just going to use that formula that I gave you. So you're just going to take the magnitude of A, multiply it by the magnitude of B, and then multiply it by sine of the angle. Okay? So we're just going to get 2 times 3 times sine 60. Okay? And so that's just going to give me 2. Oh no, I already did that. So so that's just going to equal 3 root 3. Okay? 3 root 3. Because of course this is root 3 over 2. 2's cancel, and we're just left with 3 root 3. Okay? There we go. So let's look at the unit vectors here. Drinking coffee. Anyway, so we got the zero vector, because they're the same, right? Zero vector, because they're the same. Zero vector, because they're the same. Okay? Anytime you take a cross product of a vector in itself, it equals the zero vector. Straightforward. A cross J. So this is kind of neat, and it makes sense when you think about it, because of course, what's perpendicular to both I and J? And the answer, of course, is K. What's perpendicular to both J and K? The answer is I. And I and K would give us J. Okay? Sort of obvious when you think about it, but there's the the picture to illustrate it. Okay? Yeah, because this is just your x, y, and your z axes basically. Okay. All right. So the cross product of two algebraic vectors. Algebraic vectors. Okay. So in other words, I'm giving you the components of the vectors. Okay. I'm giving you the x. I'm giving you the y. I'm giving you the z. Okay. Now there's two ways. So I'm just going to show you what the answer is as a formula. First of all, so it would be A cross B is equal to, and this one's unfortunately not as simple as the dot product, but you will get used to it, because like I say, this is more useful. So we take the y component of the A, multiply it by the z component of the B, minus the z component of the A, times the y component of the B, and we subtract those, multiply it by the I, so that tells us our x. And you'll notice that the x is the one that's missing when you're finding the x component. Okay, that's just kind of a way to remember it. I'll show you some tricks on how to do this a little easier. There's two ways to do it, to sort of be able to figure it out. One I'll show you in this video, and then the other one I'll show you in class if you ask me, because it uses some stuff that we don't actually learn in this course, but some of you might want to try. Okay, so the x and the z. Okay, so again, that's the y coordinate you'll notice that the y is the component that is missing from that part. And so then when we do the z, it is the z that's missing. So, oops. So we'll have ax by minus ay bx. And there we go. So that's it. And so for the purposes of this course, if you want to just memorize that formula, you can, and that will work. Okay, it's not necessarily the best way to do it, and as you move along, if you take, courses that use this in university, that may not be good enough, but for our purposes, it is. Okay, so another way to do it. Okay, let me zoom in here. There we go. I'm at the bottom of the page. It's harder than it looks. Anyway, so what you're going to do, another way to do it here is we do our A and we do our B. And what you're going to do is you're going to list the components. You're going to start with Y. Y? I don't know. That's how you remember. Okay? And then we write Z. Okay? And then we write X. And then we finish with Y again. Again, Y? I don't know. That's how you remember. That's how I remember anyway. And there we go. So then we do the same thing with B. Exactly the same. Okay, and B to Y. There we go. So, list them like that. I didn't underline the B. There we go. All right. And what we're going to do is to figure out the components here, we're going to take this and we're going to subtract this. That's my X. Okay, then we'll do, here, let me use red. Then we'll do this one, minus this one, and that's my Y. And then finally, we'll do this one, minus this one, and that's my Z. Okay, so what that gives me is that X is equal to, and we've got the AY, times BZ minus the AZ times BY. And of course, I'm doing this with algebra, but when you're actually writing it out like this, you can actually just write down the numbers. You don't have to write AY, AZ, AX. You can write 2, 3, 7, whatever it is. Okay? And then Y gives us AZ times BX minus AX BZ. Okay, and then we've got Z is equal to AX. Oh, that's a Z. I can't draw. Or write, whatever it's called. BY minus AY BX. Okay, and that's it. So that's probably the easiest way at this point to come up with the cross product. A little easier than memorizing that formula. Not a lot easier than memorizing the formula, but it is a little bit. And like I say, there is an alternative method here, okay? And if you ask me in class, I'll show you, but it involves matrices, which we haven't actually learned in this course. Oh, for crying out loud. And so if you ask me in class, I will show it to you, but it's not, there's a little bit of background I'll have to show you. But I think it's easier once you have that background. It's just that we don't really cover that in this course. So anyway, so let's do some examples here. So what we're gonna do for this one, we're gonna have. So we'll just, like I say, you're just gonna start by writing. So we'll do our A first, but you're gonna start with the Y. Okay, Y, I don't know. We go 0, 1, -2. Okay. And then the B, so we go -1, 2, 0, -1. Okay, and so we'll go like this, and we'll go like this. Okay, which gives us A cross B is equal to, I didn't give myself enough room. Okay, so we're going to have -2 times 2 minus 0 times -1. Okay, I'm gonna pick it up. Well, yeah, whatever. I'm gonna pick it up down here. It's because I ran out of room. Whoops. 1 times 2 minus 0 times 0, and then the z is 1 times -1 minus -2 times 0. Okay? That would be a vector. So, what we get is we have -4, and then we have 2, and then we have -1. Okay? Well, I feel like my 2 should be negative. Did I mess that up? Yes, I did. No, did I? 0 times 0 minus, oh, I got these two backwards. I see what I did. Okay. Well, let's do this. So that should be 0, 0. That should be 1 and 2. Sorry about that. And then that just makes this negative. All right, there we go. Okay, so it's not that difficult. So I'm going to leave the next two for you to try. Once you kind of get the pattern, it'll become kind of second nature. Okay. Example 3. So we're going to find a unit vector perpendicular to both of these. So what you're going to do, to begin with, we're just going to find the cross product, because that just gives us a vector that's going in the direction that we want. It doesn't have the right magnitude necessarily, but it's going in the correct direction. So what we'll do is we'll do A cross B, okay, is equal to, and so we're going to have, I'm going to do it the other way. Well, no, I'm not. I'm going to do it this way. Sorry, I'm zooming in, zooming out. I'm going to make you seasick. I need to look down at it. The problem is it's off the screen. I don't have it memorized. So let's see. So we're going to have 1, 1, 0, 1. And we'll have 1, 0, 1, 1. Okay, there we go. Now I can do it. All right. So we'll have 1 times 0, which is 0, minus 1 times 1, which is -1. And then we'll have 1 times 1 minus 0, which is just 1. And then we'll have 0 times 1, I forgot to switch to green, it doesn't matter, minus 1 times 1, which is -1. Okay, so there is A cross B. Now, what I actually want to find here, what I'm actually trying to find here is I want A cross B, because that's going in the right direction, but then I want to divide it by the magnitude of A cross B. Okay? And by dividing by the magnitude, that is changing it so that it has a magnitude of 1. Okay? So, we're going to get we're going to have -1, 1, -1, like that. And we're going to divide the whole thing by square root of -1 squared plus 1 squared plus -1 squared. Okay, just like that. Okay, and so what that's going to give us is it's going to give us, so obviously that's just going to be root 3, so we're going to have -1 over root 3, 1 over root 3, and -1 over root 3. Okay. So, that's basically it. Now we could rationalize that, but I'm not going to rationalize it because it doesn't really matter right now. Okay, so like the dot product, there are several properties of the cross product. There's actually only 6 though, so it's a little bit better than the dot product. So, rule number 1 See, and this is where the cross product is. You may remember from the dot product, I said that a lot of those properties seemed obvious. Okay, and they did. And the thing about the cross product is some of them, it seems obvious, but it's the opposite of what you would expect. So it's not obvious at all. So for instance, A cross B is not equal to B cross A. What it is equal to negative B cross A. Okay, that's called the anti-commutative property. Okay, if I have K times A cross B, then, well, this one is sort of what you would expect. So this one is just the same as KA cross B, which is also equal to A cross KB. Okay. If we have A cross B plus C, this is one that is what you would expect, but remember that the order is important when you do this. So it's A cross B plus A cross C. So make sure you have the A in the front because it was in the front when you were doing the cross product in the first place, okay? Because that is different. Okay, so A cross B equals 0. So what that means is it means that it can be a couple things. It can either mean that A is the 0 vector. It can mean B is the 0 vector. Or it can mean that A and B are collinear. Okay. A cross the 0 vector is just the 0 vector, and then A cross A, we already talked about that, is the 0 vector as well. Okay? So, what we're going to do here is I want you to decide for each one whether it's a scalar, a vector, or it's meaningless, because some of them just are nonsense. Okay? So, for instance, this one here, this first one, so we do have to follow BEDMAS, obviously. So we would do this first. So we got a cross product, which is going to give us a vector. And then we're going to add a vector. A vector plus a vector is a vector. Okay. This one, we're going to have a, let's see, so we're going to do the dot product first, and that's going to give us a scalar. Then we're going to add a vector and a scalar. And there's no such thing. That's an example of what I'm talking about when I say meaningless. Meaningless. Okay? This one here, we've got a vector here and a vector here, and we're subtracting them. So that's going to give us a vector. Okay? And then we have a dot product first, which will give us a scalar, and then we multiply by a vector. You'll notice it doesn't have a dot or a cross, and that's okay because it is a, you only have to have that when you're doing, or you should only have it even when you have a vector and a vector. So it's a scalar times a vector, which will of course just give us a vector. Okay, we got a dot product, which will give us a scalar, and then we cross product with a vector, which you can't do. A scalar cross a vector is meaningless. Okay? So you get the idea, I hope. I want you to do the next 4 on your own, and then we'll take those up. And then I want you to move on to example 5, which we will take up in class. So that's all for this time. Until next time, go Sabres.